Um, yes, now we are in competence level 4. This unit is about logic gates. I think most of you have may learned about logic gates, but we have to start with very basic concepts. If you think about the entire lesson, it includes basic logic gates, then combinations of logic gates, the ways of simplifying these logic gates combinations, then how to construct truth tables and circuits, and there are Boolean algebraic rules and Karnaugh maps also. I mean various methods for simplifying logic gates. So we can see questions mainly in paper 1 and paper 2 in the part B. The first question is from logic gates. So this unit is a main unit for obtaining marks in the A-level exam. So it is a very important unit anyhow. With this part, I would like to introduce logic gates. Actually, a logic gate is a small circuit. It is an electronic component. We call it as a small circuit. Why? We need such small circuits in order to build up a main circuit. So gates are actually building blocks. When you think about the central processing unit of a computer, it has made of logic gates. So that's why they have introduced logic gates in order to understand the structure of the CPU. In addition to that, the gates are used to make circuits. This type of circuits are used in our day-to-day activities, especially for automated things. Right. So this is about idea of the entire unit. I would like to show you the main concepts behind the logic gates. Actually, all the gates are physical things, but they are created on the basis of Boolean mathematics. So Boolean algebra is a part of mathematics. It has three main operators. They are called NOT and O. Let's see. In Boolean mathematics, there is an operator called NOT. NOT means negation. So we say NOT in the sense negation, the opposite of a value. The Boolean mathematics has got two values called Boolean variables. They are 1 and 0. So let's see how you can understand. For example, there is a value called A. A actually implies the value, but we don't know what is the actual value inside A. It can be 1 or 0. In Boolean mathematics, if you take any variable, a variable in the sense of value which can be varied, how it can be varied? It can be 1 or 0. So what is the negation? If we have A as 1, the negation is called not A or A bar. We call it as A bar. So if A is 1, A bar will become 0. If A is 0, what may happen to A bar? It is 1. So that is negation. I think you have taken that point. Not operator in Boolean mathematics. Then I would like to show you the second operation. Second operator, that is actually AND. If you take AND operator, it means multiplication. Multiplication. Sometimes we explain it as conjunction. Conjunction. We need two values in order to understand the multiplication. So I would like to take A and B. What may happen? After multiplying A and B, we are going to take the output as A and B. Now, how you can understand A and B? There may be 4 possibilities. The reason is as 2 values. If there are 2 values, you take 2 to the power 2. It is 4. So then there are 4 combinations. Let's see. A can be 0. B also 0. One possibility. A can be 0. B can be 1. A can be 1. B is 0. Both values can be 1. These are the possibilities in Boolean variables. So now we have two. Variables and we have assigned values. Then do the multiplication. 0 into 0. Here 0 into 0, 0. 0 into 1. It is always 0. Why? If you do any multiplication with 0, the result will become 0. Then 1 into 0. 1. 1 into 1. 1 into 0 is always 0. Then 1 into 1 is 1. So this is how we understand the AND operator. See, there are 3 occasions we get 0. And then 1 into 1 is 1. Conjunction in the sense, we have a word called conjunction here. Conjunction in the sense, if both values are 1, then only we get 1 as the output. That is conjunction. So this is the main idea about AND operator. Then I would like to discuss the third operator, that is O. O in the sense, if you take O O operator, it is called addition. This is Boolean addition. It's okay. And now you see Boolean addition. Um, Sometimes we call it as disjunction. Disjunction. Then we need two variables called A and B. The result will become AOB. AOB as the addition. So the same possibilities. Now you know 0 and 0, 0 and 1, 1 and 0, 1 and 1. Actually, if you see the values, this line says 0, 1, 2 and 3. So as there are 4 situations. Now what may happen here, 0 or 0 is always 0. 0 or 1 is always 1. 1 or 0 is always 1. 1 or 1 is always 1. I think the last row you have to think about here. 1 and 1 is 1 in Boolean mathematics. This is not a binary addition. As you know, these numbers are binary numbers. So if you add 1 and 1 using binary mathematics, the answer is 2. 1 and 1, it can be 2. We say it as 1, 0. But here, it should be 1. So these are the 3 operators. These operators are in behind developing logic gates. Now in this lesson, I would like to discuss basic logic gates as the next section. Okay. Now I need to show you there are 3 basic logic gates. They are very important. Basic logic gates. Why? All the complex gates are behind these 3. First one is called NOT gate. NOT. I don't need to discuss all the things about NOT gate here, but I explain few things. One important thing is the NOT gate has got a single input and a single output. Let's see how to draw it. We always draw NOT gate with this symbol. We call this symbol as the inverter. This is the inverter. as a single input. Suppose A is the input, so output is A bar. If you input 1 here, what may happen? You will receive 0 here. This is the nature. But what else? In any situation, if you input 0 here, you will get 1 here. This is the NOT gate. But then after that, this is the way of drawing. I would like to show you now how to draw this gate. You should be familiar how to draw. And there is an output here. This output A bar can be explained as an expression. Not only the gate, we have a Boolean expression also. It is a Boolean expression. So, Boolean expression A bar. Boolean expressions can be written like this: F equal A bar. Why we take F? F is a variable. It is a popular variable to get the output. You can use any word: Z equal A bar, B equal A bar, anyhow. But the famous variable is F equal A bar. Boolean expressions. Expression says what is the output. Now this is the gate symbol. This is the output. Another thing. Now this is the first one, the gate. The second one, the Boolean expression. Third one, I would like to another thing. That is the truth table. Truth table. Truth table is a table. It shows you the combination of inputs and outputs. How you see all the input and outputs. Now, in NOT gate, we have only one input and one output. So the truth table would be like this. We have A, and we will take A bar. What are the input? It can be 0 or it can be 1. If we input 0, we get 1 here. If we input 1, we get 0 here. This is truth table. So there are 3 components with the NOT gate. The gate symbol, then the Boolean expression, and the truth table. So there may be more than these 3 components. I think it is better to discuss some areas in later with different examples. Now, up to this, you can understand the NOT gate with these 3 features. Okay. Right. Then I think you may have understood, all of you may have understood this gate. So then I'm moving to the next part. What is that? AND gate. The second gate is AND. This is AND gate. How you can get idea about AND gate? You need two variables in order to draw the AND gate. So there are two variables. This is the symbol AND. I would like to take they as A and B. So output is A and B. Even without having a dot, you can show A and B, the multiplication. I would write the Boolean expression here. If you take a Boolean expression, A and B, so F equal A and B. But in this example, I show only A and B, but there are possibilities. It can be A and B and C, A and B and C and D. Values can be entered with the variable here. So I would like to show you how to get the truth table. Now it is easy. We have only A and B. We have A and B. So we go for output A and B. Now you know the combination 0 and 0, 0 and 1, 1 and 0, 1 and 1. Right. This is the AND gate. So 0 into 0 is 0. 0 into 1 again 0. 1 into 0 again 0. 1 into 1 1. So this is the idea. So we have three things. This is the gate. This is the Boolean expressions, and this is the truth table. Rather than these three, I would like to show you a small example to understand the AND gate here with a simple circuit diagram, a very simple circuit. We can draw it like this. I would like to draw here a circuit here. Suppose we have a battery, and power goes like this, and there is a bulb here. In order to now see, we have a switch here and another switch here. Switch A and switch B. A circuit has been designed. With two switches. if the switch is open like this, open in the sense the electricity cannot pass through the cable or the wire. So what may happen, as there are two switches, we want to close them. If we close here, then only the power can pass. See the first situation here, 0 and 0. Both switches are open. So electricity power cannot be passed. So in the second line, you can see the first one is still open. We can close the second one. See? But there is no way to pass electrical power. In the third line, if you close the switch 1, then switch 2, switch B is open, so there is no way to pass electricity. But in the last row, 1 and 1, it means the both switches are closed. If both are closed, see, only power can be passed through the line, and then the bulb will be on. So this is a small example. Two switches, they are in a parallel manner. So both switches should be closed in order to read the bulb here. So you can understand the AND gate with the simple example, with the simple circuit here. Why we did not make a circuit for the NOT gate? Actually, we have a circuit. Later on we will do it. It is better to understand this circuit now, and later we will discuss about NOT gate circuit. Okay, then you can understand the simple AND gate. This is a simple AND gate. But I want to show you something. These things. Suppose what may happen if we input 3 values, A, B, and C. So you can write the output easily. F equal AN, BN, C. The gate can be modified. Gate can be modified using such a design. So if we have 3 values, number of values are 3, we take 2 to the power 3. 3 in the sense these 3. 2 to the power 3. 2 to the power 3. So then we need 2 to the power 3 means 8. We need a truth table. A, B, C. These are the values. And the output is here AN, BN, C. Then you see the output AN, BN, C. Now 2 to the power 8 means 2 to the power 3 means 8. So we have a different truth table now. There are 8 rows. 2 to the power 3, it means 8. So we need 8 rows. I would like to show you. You have to write as 1, 2, 3, 4, 5, 6, 7 here. It is easy if you write it like this. 4 zeros. You can directly write 4 zeros and 4 ones. as A. Then write in B, 2 zeros, 2 ones, 2 zeros, 2 ones. For the C, 0, 1, 0, 1, 0, 1, 0, and 1. If you see this table carefully, the values can be seen. 0, 1, 2, 1 and 2, 3, 4, 1 and 4, 5, 2 and 4, 6, 1, 2, 4, 7. Sorry, I have written like this. It is easy. Now, how to fill this? We have to do one by one. 0 into 0, 0. So again 0 into 0, 0. 0 into 0, 0. 0 into 1, 0. 0 into 1, 0. Yes, 0. 0 into 0, 0. 0 into 1, 0. 0 into 1, 0. 1 into 0, 0. 0 into 0, 0. 1 into 0, 0. 0 into 1, 0. 1 into 1, 1. 1 into 0, 0. 1 into 1, 1. 1 into 1, 1. This is the output. So, if you got an AND gate with 3 variables, you can draw the circuit like this. This is the way. Right. Then even if you have another value, it is very similar. 0 into 0, again 0 into 0, and again 0 into 0. So, number of variables can be varied. We can see different number of variables, but the idea is here. Right, then I would like to move to the OR gate. So it would be the last logic gate. OR gate. You need 2 values for the OR gate also. I would like to draw that's a curve like this, and this is the way of drawing that OR gate. A and B are the inputs, so output can be A, O, B. Now, you can write the Boolean expression here. You say F equal A, O, B. Right. So then you have changed. Now you know the circuit and Boolean expression. What about the truth table? I would like to draw the truth table. We have A and B. So output would be A, O, B. Combinations, as you know, these are the combinations. Right. Now how to add it? 0, O, 0, 0. 0, O, 1, 1. 1, O, 0 is always 1. 1, O, 1 is always 1. As I told you, 1, O, 1 is 1 in Boolean algebra. So then, you can understand the truth table and the symbol. And if you go for a circuit, what may happen? If you go for a circuit, this is a battery. We have a bulb here. But this time they use a different circuit. It has 2 switches. can see them like this. This type of circuit. So what may happen if you now we have switch A here and B here. So you have a parallel structure, switch goes parallelly. So if both switches are open, electricity cannot pass through the circuit. But if we open switch A and close switch B, then electricity can pass through this line. See? So then the bulb can be on. If A is here, if we close switch A, then electricity can pass through the circuit and bulb can be lit. If we do both 1 and 2, even both, there is a possibility to pass electricity through the entire circuit. So then bulb can be lit. So this is the way of OR gate. So here you see a parallel circuit structure in order to get an idea about the OR gate. So these are the 3 basic gates. Now what you can do, you can think about 3 input or even 4 input. You can think about this type of things. I would like to show you something. Suppose we have a 4 variable OR gate. What may happen? So we have A, B, C and D. We have A, B, C, D. Number of variables are 4. So 2 to the power 4 equal 16. You need 16 rows in order to identify the possibilities. This is the last level. We don't go beyond 2 to the power 4. This can be the last level in a level exam or in different circuits designs. So then there are 4 variables. You name them A, B, C, D. How? You have to write from 0 to 15. What about the output? Output can be A, O, B, O, C, O, D. So it can be 8 zeros. 4, 5, 6, 7, 8 and 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Then 4 zeros, 4 ones. Again 4 zeros, 4 ones. This time 2 zeros, 2 ones, 2 zeros, 2 ones, 2 zeros, 2 ones, 2 zeros, 2 ones. Here 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So you have to continue the same pattern and fill the truth table. So 8 zeros, 8 ones, then 4 zeros, 4 ones, 2 zeros, 2 ones, 0, 1, 0, 1. Then you can calculate. So here 0. In all other occasions that you can get 1. Why? In each row we have a 1. So output can be 1. Here 1. What is the important thing here? If you have any number of ones, I mean if there are 3 ones or 4 ones, the same output is 1. So suppose you have 4 ones, you get the output as 1. Okay, I would like to actually say something here. These 3 gates are behind all above other circuits. So it is better to draw all these things in your notebooks and then try to practice them, truth tables and other things. Then you have an idea. It is easy to start the combinational logic gates in the next section. Okay, right. Let's see the next section.